Good morning, students. In the last class we discussed the numericals on the basis of Young's modulus as well as shear modulus. On this today class I am going to discuss the numericals on the basis of bulk modulus. Already we know that what is this bulk modulus? Bulk modulus is the ratio of volume stress to volume stress. Volume stress to volume strain. Here volume and bulk modulus are with respect to the stress terms only. Listen here. Bulk modulus is inversely proportional to compressibility. Already we discussed this thing. Here in this bulk modulus, the volume stress, always keep in your mind, stress means force acting per unit area. Volume strain means change in volume with respect to original volume. We can say that Fv by A into delta V. We can also convert this force acting per unit area is nothing but a pressure by delta V. Bulk modulus K, which is equal to PV by delta V. This relation we can use to solve these type of numericals, and keep in your mind bulk modulus is inversely proportional to compressibility. Why? Because if the bulk modulus value is more, the compressibility is less. The compressibility is more, bulk modulus value is less. Keep in your mind, this is the very important here to solve the numericals on the basis of bulk modulus, that too in the form of liters or in the form of pascals or in the form of volumes. We can convert that liters in the form of volumes and in the form of compressibility, and this formula help us to solve the numericals, and this is the basic bit of this bulk modulus. Already we discussed these things in the last lectures. Okay, we'll solve the numericals. In the last class we solved numericals on the basis of shear modulus as well as Young's modulus. And the today class I am going to discuss the numericals on the basis of bulk modulus, and this is the last bit, and we should solve these type of numericals. Okay, numerical number 7. Just see here, what are the things they are given. Compute the bulk modulus of water from the following data. We should find the bulk modulus of water. Bulk modulus of water from the following data. Listen here. They mention the initial volume. Just you write separately what they mentioned. Initial volume VI. I indicates initial volume which is equal to 100 liters. I will explain how to convert liters to volume. And then they mention the pressure increases 100 atmosphere. Pressure increases 100 atmosphere. And also they mention 1 atmosphere is equal to 1.013 into 10 to the power of 5 Pascal. We can say that here nothing means 1. What is the value of 1 atmosphere? 100 into 1.013 into 10 to the power 5 Pascal. Now this is the pressure increased value. These are the given values already mentioned in the question. And what is the final volume? That is how to convert liters to volume. keep in your mind 1 liter is equal to 10 raised to minus 3. 1 liter is equal to 10 raised to minus 3, or keep as it is. Final volume which is equal to 100.5 liters. Initial volume is 100 liter and final volume is 100.5 liter. The bulk modulus of water with that of air at a constant temperature. Listen here. This bulk modulus with that of air at a constant temperature. Explain in simple terms why the ratio is so large. We don't know, but they mention the ratio is too much large. Why that ratio is large? We should explain that in simple terms. Before going to explain that ratio large, just keep in your mind, compute the bulk modulus of water. We should find the bulk modulus of water first. And already they mentioned the bulk modulus of air at constant temperature. It means that bulk modulus of air is 1.013 into 10 to the power of 5 Pascal. Already they mentioned in the question, the ratio is too much large. Means that definitely our answer should be greater than this value. Otherwise, the ratio is not going to large. We should explain that ratio term only. If the ratio is large, then only this question is correct. Otherwise, the question itself is wrong. Okay? Our answer must be greater than this value. Keep in your mind, this is 1 atmospheric is nothing but a bulk modulus of air. Okay. Next term given values is 1 Pascal. Already we know that Pascal is nothing but Newton per meter square. Okay, these are the things. And one more thing they mentioned, otherwise always keep in your mind, bulk modulus of materials. Already we mentioned in the form of tables. But here we should find the bulk modulus of water. And what are the things? Bulk modulus of air is, bulk modulus of air is 1.013 into 10 to the power 5 Pascal. Okay, these are the things they mentioned. Now, what is the formula for bulk modulus? Bulk modulus which is equal to bulk modulus which is K, which is equal to PV by delta V. Pressure, and this is the volume, and this is the change in volume. Already we know that change in volume we can write the general formula, that is final volume minus initial volume. We can find the change in volume by the given data, that is final volume minus initial volume. What is the final volume? That is 100.5 liters minus initial volume is 100 liters, that is delta V, which is equal to 0.5 liters. The change in volume, that is 0.5 liter. Then what is the initial volume? That is 100 liter. If suppose we want, that is volume strain, which is equal to already we know that change in volume by original volume. This original volume is nothing but a initial volume. That change in volume is 0.5 liters and initial volume is 100 liters. And these are things are going to cancel. Already you know that strain is no units, that is nearly is equal to 5 into 10 raised to minus 3. This is volume contraction, that is delta V by V, which is equal to 5 into 10 raised to minus 3. Now the pressure increases. Already they mentioned pressure increases. P is equal to 100 into 1.013 into 10 to the power of 5 pascals. Keep as it is, don't multiply. These things are going to cancel. Keep in your mind. Or if you want to multiply means, what is the answer means? That is nearly about 1.013. Just to convert these values. This is 10 to the power of 2 into 1.013 into 10 to the power of 5. Bases are same, power should be added. 10 to the power of 2 and 10 to the power of 5 is 10 to the power of 7. And this is keep as it is, 1.013. And this is Pascal as it is. What is the pressure increases? 1.013 into 10 to the power of 5 Pascal. If you don't want to multiply, keep as it is, things are going to cancel. If you multiply means also nothing is going to change. Now substitute these values. Pressure increases how much times? Pressure P, which is equal to 1.013 into 10 to the power 7 pascals. We got change in volume with respect to original volume and pressure. Just substitute in this formula. In the bulk modulus formula, that is K, which is equal to PV by delta V. Shall I write V in the denominator form? That is K, which is equal to P by delta V by V. We can write like this also. Now K, which is equal to, what is pressure value? That is 1.013 into 10 to the power of 7. And change in volume with respect to original volume, how much? That is 5 into 10 to the power minus 3. 5 into 10 to the power minus 3. Just take that numerical form, that is minus 3 becomes in the form of numerator. If suppose we convert numerator means, that is 10 to the power of plus 3. This is 2.02 something. You just calculate yourself. Almost this is double. 5 ones are 5 twos are. Again this is 5 twos are. 2.20 something into 10 to the power of around this decimal point 22 means this is 22 point. We are considering here decimal point is going to shift. 0.220 into 10 to the power. This is already 10 to the power of 7 and this minus comes to the numerator means plus. Bases are same, power should be added means 0.22. This is 10 to the power of 10. Bases are same, power should be added. 7 plus 3 is 10. Now we can convert 2.2 approximately. You calculate yourself. I calculated here approximate values, that is 2.2 into 10 to the power of 9 Pascal. And this is the bulk modulus of water. Bulk modulus of water is 2.2 into 10 to the power of 9 Pascal. And bulk modulus of air is 1.013 into 10 to the power of 5. Listen here. Why the ratio is so much large? Bulk modulus of water with respect to bulk modulus of air. If suppose we consider means this is 2.2 into 10 to the power of 9 Pascal and this is 1.013 into 10 to the power of 5 Pascal. Bulk modulus of water is more as compared to air. Why this ratio is so much large means, always keep in your mind, air or gas molecules more compressible than water. Already we got the relations. What is that relation means? Bulk modulus is inversely proportional to compressibility. Okay, if the compressibility is more, bulk modulus value is less. Air compressibility is less, that's why compressibility is less, bulk modulus is less, compressibility is more. If the compressibility is more, bulk modulus value is more, compressibility is less. Which bulk modulus is more? Water bulk modulus is more, that's why the compressibility is less than air. Why the ratio is so much large means the compressibility of water is less than air. Intermolecular force and interatomic force in air and water are different. In air is more compressible as compared to water. Why? Because intermolecular force is more in air as compared to water. This is the first numericals on the basis of bulk modulus. Just note down. Very important. Compressibility is inversely proportional to bulk modulus. Why this ratio is so much large means air or gas molecules more compressible than water. More compressible than water, or you mention here gas molecules more compressible than water. This is why the ratio is very much high. Is it clear? We move towards next question. Okay. Okay, next question. Compute the fractional change. Question number 8. Compute the fractional change Okay, next question is the compute the fractional change in volume of a glass slab when subjected to hydraulic pressure of 100 atmosphere. Bulk modulus of elasticity of glass is 37 into 10 to the power of 9 Newton per meter square, and 1 atmosphere is equal to 1.013 into 10 to the power of 5 Pascal. Fractional change in volume. Fractional change in volume is nothing but delta V by V. V is nothing but delta V by V is nothing but fractional change in the volume. Fractional change in the volume. We should find this change in volume with respect to original volume. We should find this change in volume with respect to original volume of a glass slab with subjected to hydraulic pressure. This is the one type of pressure we will study this hydraulic pressure in the next chapter, that is mechanical properties of fluids. Now just to keep in your mind, hydraulic pressure is 100 atmosphere. Hydraulic pressure is 10 atmosphere. What is the value of 1 atmosphere? 10 atmosphere. ATM is nothing but atmosphere. How much atmosphere here is? 1 atmosphere. 1 atmosphere means 10 into 1 atmosphere value is 1.013 10 to the power of 5 Pascal. This is the standard value. And hydraulic pressure is around 1.013 into 10 to the power of 6 Pascal. This is the hydraulic pressure. This is 10 atmosphere is nothing but 1.013 into 10 to the power of 5 Pascals. These are the things are given in the question. And bulk modulus of glass bulk modulus is 37 into 10 to the power of 9 Newton per meter square. This is also they mentioned. Now the formula for bulk modulus is bulk modulus, which is equal to bulk modulus is equal to PV by delta V. We can also say that bulk modulus K, which is equal to P, write as it is, take this V in the denominator, that is V by V. We can write like this. We want change in volume with respect to original volume as fractional change in the volume. Just send this side and take this side. P by K. What is the value for pressure increased? Hydraulic pressure increases how much? That is 1.013 into 10 to the power of 6 Pascal. And bulk modulus is 37 into 10 to the power 9. And the final answer after calculation, that is around 2.74 into 10 raised to minus 5. 2.74 into 10 raised to minus 5. What is the unit? Change in volume with respect to original volume is nothing but a volume strain. There is no unit for strain quantities. Fractional change is fractional change in volume is that is 2.74 into 10 raised to minus 5. This is the very small values. This much of fractional change occurs in that glass slab. We can find any other slab also. We can find water medium also, or we can find the steel. We can find other substances also by using this bulk modulus concept. We'll move next question. Please note down. These are the very important question for the NEET as well as JEE. Next question is, determine the volume contraction of a solid copper cube solid copper cube 10 centimeter on an edge on an edge when 10 centimeter on an edge when subjected to a hydraulic pressure subjected to a hydraulic pressure that is hydraulic pressure of 7 into 10 to the power of 6 Pascal 7 into 10 to the power of 6 Pascal bulk modulus of copper is 140 gigapascal. This is the question. We should find the bulk modulus, volume contraction, that is delta V, volume contraction, that is delta V. Determine the volume contraction, change in volume of a solid copper cube 10 centimeter on an edge when subjected to a hydraulic pressure of 7 into 10 to the power of 6 Pascal. Bulk modulus of copper is right here. Hydraulic pressure of 7 into 10 to the power of 6 Pascal. Bulk modulus of copper is, just to mention the given values as it is. Edge, given data, that is edge is nothing but is shall be considering as a length, that is L is equal to 10 centimeter, or we can also say that 0.1 meter. Now subjected to hydraulic pressure, that is P, which is equal to 7 into 10 to the power of 6 Pascal, and bulk modulus of copper, which is equal to 140 into 10 to the power of 9 Pascal. 10 to the power of 9 is nothing but gigapascal. We should find the volume contraction, that is delta V. How to find the original volume? We know that volume which is equal to length into breadth into height. Here we know that on an edge how much, that is the cube means all sides are equal. Length, breadth and height is nothing but a volume. Just to consider 0.1 into 0.1 into 0.1, that is nothing but 10 raised to minus 3 meter cube. Volume which is equal to 10 raised to minus 3 meter cube. We can convert that in the form of or we can take directly, that is 0.13 cube, or you convert like that. Now this is about volume V. Just to find the change in volume, what is the formula? That is K is nothing but a bulk modulus, that is PV by delta V. We want delta V which is equal to PV by K. Now substitute the values. Volume contraction, that is delta V, which is equal to pressure is how much? 140 into 10 to the power 9 into volume is 10 raised to minus 3. Denominator is, that is K, which is equal to P is, just to write the pressure value. What is pressure? 7 into 10 to the power 6 into volume is 10 raised to minus 3. Now, what is the bulk modulus values? That is 140 into 10 to the power 9. If suppose this 9 will come to the numerator, means minus 9 plus 6 means minus 3 minus 3 minus 3 minus 6, and just to calculate, that is change in volume is how much? The final answer is change in volume is, that is 5 into 10 raised to minus 8 meter cube. 5 into 10 raised to minus 8 meter cube, or we can also say that change in volume which is equal to 5 into 10 raised to minus 5 into 10 raised to minus 3 meter cube. We can write by splitting 10 raised to minus 8, 10 raised to minus 5 and minus 3. 10 raised to minus 3 is nothing but milli, change in volume which is equal to 5 into 10 raised to minus 5 millimeter cube. Millimeter cube. This is the final answer. We can say that volume contraction is this much. The contraction of volume contraction is, that is delta V, which is equal to 5 into 10 raised to minus 5 millimeter cube. Very important, this type of numericals many times they asked in the NEET as well as JEE. Okay, just note down. And the next numericals and last numerical, that is, I am going to conclude and I am going to complete this chapter by solving the next numerical, that is numerical number 10. And these are the numericals are very important for the purpose of your upcoming test as well as upcoming theory examination, NEET examination, and as well as Karnataka CET examination. These type of numericals they are going to ask. Okay, next and last numericals, and these type of numericals also they may ask, how much should be pressure how much should be pressure how much should be pressure on a liter of water be changed to compress it by 0.10%, 0.10%, question mark. In the bracket they mention bulk modulus of elasticity of water is bulk modulus of elasticity of water is, that is 2.2 into 10 to the power, already we solved this first numericals, that is 10 to the power of 9 Newton per meter square. Already we solved this bulk modulus of water as compared to air, that is question number 7, first numericals of this class. Okay, we should find the how much should be a pressure on a liter of water to change to compress it by 0.1%. Change to compress means definitely that is change in volume. If the change in volume is 10%, what is the original volume? Listen here. We can say that originally it is 100%. That may be changes to 0.1%, 0.10% or 10% or 70%, 80%. These are the 70, 60, 10 and 0.1. These all are the changed value. After a certain time or a certain temperature or a certain incident or a certain work done, volume is changes. The initial volume is definitely it is 100%. Now in this question also they mentioned a liter of water be changed to compress it by 0.10%. The bulk modulus of elasticity of water is this much they mentioned. We should find the pressure on a liter of water. How much should be pressure on a liter of water? We should find the pressure P. The given we should find pressure P and the change in volume, that is 0.10%, and bulk modulus, that is K, which is equal to 2.2 into 10 to the power of 9 Newton per meter square. This is the bulk modulus value. This is the bulk modulus value, and keep in your mind, this is the change in volume. What is the original volume? Definitely that is 100%. V, which is equal to 100%. If change in volume by original volume, which is equal to, what is change in volume? That is 0.10%, and original volume is, that is 100%. This percent are going to cancel. 0.1 by 100 is nothing but 10 raised to minus 3. This is the volume contraction with respect to 100%. Now we should find the pressure. Okay, what is the general formula? Modulus of elasticity K, which is equal to PV by delta V, or we can also write K, which is equal to P by delta V by V. We want P, send this side, pressure P, which is equal to K into change in volume with respect to original volume. What is the K value? That is 2.2 into 10 to the power 9. What is the change in volume? That is 10 raised to minus 3. And now the pressure is 2.2 into 10 to the power 6 Pascal. Why it is 10 to the power of 6? Bases are same, power should be add, that is plus 9 minus 3 is nothing but 10 to the power 6. That is 2.2 into 10 to the power of 6 Pascal is the pressure should be on a liter of water be changed to compress it by 0.10%. You may find 0.2%, you may find 10%, you may find 40%. If the compression of water is changed to 40%, find the how much pressure is going to act on that liter of water. You can find by using this relation. This is the basic relation to find the compression as well as pressure as well as bulk modulus. And these are the numericals will help us to find the Young's modulus, bulk modulus, shear modulus. Okay, in the upcoming examination, the unit test 2 is, that is total mass is 50, mass. In this 50 mass, the 50% of syllabus is gravitation and remaining 50% syllabus is mechanical properties of solids. Mechanical properties of solids, 50% is nothing but 25 mass. Keep in your mind, we are covering the mass up to 25 mass. Definitely we are going to ask in the 1 mass question also, 2 mass question also, 3 mass question also, and 5 marks as well as numericals. Just go through these lectures and do well, and these numericals you practice yourself. If you not practice, means definitely these numericals are going to tough, and it is not easy to solve by seeing the numericals. You just go on practice, and all the best for your examinations. Thank you.